And they ask you the number of classes. Number of classes, number of bars. 7. The frequency of the class with the least frequency, the smallest bar. The smallest bar is this guy right here, and they wanted its frequency. So you kind of have to estimate, and you can estimate it to about 1. If you bring this guy over here, if you put 1 or 2, I'm fine with that. If you put 6, then you're really off. So just in the ballpark. The frequency of the class with the greatest frequency. Here's your class with the greatest frequency. Its frequency, if you estimate, 23, 24, somewhere in there. God bless you. Your class width. Your class width, remember when we made your tables? You took your midpoint. You added your class width all the way down. So the difference between 2 midpoints is your class width. Everybody can do this? If you don't have it, you should be working on it. If the difference between any 2 consecutive midpoints is your class width. Ready? Yeah. The difference between your midpoints is your class width. You know when you make a table and you do your midpoint and then you add your class width all the way down. That has to stay the same. Okay, again, they gave you another graph. This is a nice exercise in interpreting your graphs. This is what is this kind of graph? OJI. This is an OJI. Good. This is your cumulative frequency graph. It starts and it never ends. It increases and then never decreases. So the number in the sample when you do a cumulative frequency is the number that it ends up with. That number at the top. This number here is this right here, 50. Okay? A lot of you were having trouble with that yesterday. Think of your table. When you do the cumulative frequency part, you're adding, you're adding each one. It's the number of the total data that you use. The location of the greatest increase in frequencies. This is a nice one to find where they jump here, from here to here, from here to here. Look at this guy, from here to here. That's the greatest one. The greatest jump by the group, from here to here. So from 64 to 66. That's all we know how to say. We read the graph, we don't know what else they want us to say, from 64 to 66. From the same graph, a cumulative frequency for a height of 72. Here's your height over here, 72. Follow your 72 and see what your cumulative frequency is. My bar is a little bit off. So it's like right before the 50. 40, 47, 48, 49. It's like right before the 50. The number of adult females that are between 62 and 66. Let me get this other stuff. So between 62 and 66, find this point and find this point and subtract your points. Okay? So you're going to subtract 25, that over here, minus 5. That's how much it grew from there to there. So that's 20. Minus B. The height for which the cumulative is 25, follow it across till you intersect and come down. It's about at the 66. As long as you're in the ballpark, that's fine. Now this one's not so bad because they did by every 2, but they incremented every 1. So that one's not so bad. It's harder to find when you go like by 10s or by 5s. It's harder to see, was it a 3 or was it a 4 or a 2? So as long as you're in the ballpark, it's okay. That's why a lot of times on the bars you put your frequency on the top of your bars. The number of adult females that are taller than 70 inches, here's your 70. You want how it grew from here to here. That's the number that are taller. So 50 minus 40. Oh, sorry, 50 minus 44. So somewhere in there. So about 6 of them. 45, 44, 43. You're close enough. Questions on reading these? No? Or did you find yourself within the ballpark for these? Yeah. Okay, another nice one to interpret. This is another bar graph. This is a relative frequency. This is nice too because look how they did their y-axis for relative frequency. They put it in a percent. Rather than say 0.10, 0.20, 0.30, 0.40. This is your part over whole. Yes.
I can break it back. When it asks for the frequency experience.
You can. That's fine. Well, when I was telling you the other day, a lot of business people like percents. When you're like running the company, you don't want to hear, 0.10, and we have to say that 10 hundredths. You don't even want to hear that. You want to hear 10%. I can think of my company, it's gaining 40%. I've dropped 30%. I'd rather hear a percentage than I would 30 hundredths, 3 tenths. We don't really say like those kind of things. So they like percents on those. So that's why a lot of times relative frequency, you see them flip it to a percent. Identify the class. You're looking for the class with the greatest frequency and the least frequency. Highest bar, lowest bar. Highest bar, lowest bar. Okay? Now, these are the midpoints. If your midpoint is one away here, what do you think your class went to without the class boundary? If this is your midpoint, what would this guy be right here? 17. What would this one be? 18. Okay? So your class probably went from 17 to 18. Give or take your class boundary in here. Your class is really small. It's a very small class. They kind of loop them together really tight in here. Your midpoints are only one apart. And that's not even counting your class boundaries. So your class width is really small. It's less than 1. Approximate the greatest frequency. They just wanted to ask you, what does this line come up to? 40%. What does this line come up to? And here's one that's a little harder to tell because it's 10%. If you gave me 2, you gave me 3, even 4, as long as you didn't give me 5, I'll be okay with that. Approximate the relative frequency of the second class. Here's your second one. And again, 33, 34%, 32, as long as you're in the ballpark. Okay? That's why a lot of times they put them on top of the bars. They'll put it up here, 40%. They'll put it over here, 2%. They put it at the top of the bar, especially if you have too big of a y-axis difference. And another one, what kind of graph is this? What kind is it? Polygon. Very good. Frequency polygon. This is your frequency polygon. It's the same as your bar graph, except for it's a line segment, and they're not smooth. They're segments. Okay, so the class with the greatest frequency is this guy. There's the highest one you got, so this one right here. The class with the least frequency, the smallest, doesn't count this one or this one. Because remember you have to expand them on the ends, so it doesn't count those. So it looks like this guy is your least frequency. So what's between 6 and 7? 6.5. Everybody's good with these? Alright, here's your tables. You have to make sure you understand how to make this table. Because without this table, if you don't get your classes right, everything's wrong. So you find your max and your min for your data. You subtract them. You divide by how many classes. And we'll tell you how many classes. I'll tell you. The book always tells you. I want 5 classes. I want 8 classes. I want 6 classes. Eric, question?
You sign up for class with units supposed to go across units.
No. Because remember, if you go across, you're always short 1. Because if in between these two, 32, 33, 34, 35, or 4, that only shows you 3. Because you're going to have to subtract and add 1. So your class width go this way, consecutive, either lower boundary or upper boundary.
You would never want to like get a class with that's in the decimal.
It depends. If your data is in decimals, yes.
But
If your data has
you
decimals
wouldn't
in
go
it,
up, but you wouldn't go down to
well, we always round up to the highest number. We round up to the highest whole number. So you're not going to get a class width of a decimal
I'm
here.
just saying, like, you wouldn't just use 3.8 as a class width.
No, you have to go to the highest point. And I shouldn't say no, never. What happens is sometimes you have data that is all in decimals. Like, say you're doing, like, gas prices. $4, and, you know, they go out to 3 decimals. $3.675. You may run your data with decimals, but then you're going to have to figure out your class with a decimal in it. But you don't want to round up to the highest number, right? Then you won't have a big difference in your classes. So if your data is in decimals, but right now our data is discrete, it's not decimals, it's whole numbers. So for us, we're gonna follow that rule. You have to follow a different rule if your data is in decimals, which makes it so difficult. And when we get to like standard deviations and variances, we talk more variances and standard deviations of those things rather than set them up in tables. Question here?
Yeah, no. I didn't count like the first number when I did the class width, so I messed up.
Yeah, so you messed up your table. This
Yeah.
guy has to be your min number. This has to be your min. You start at your min.
Yeah,
Now, and you go all the way through to your max. Now watch what's gonna happen. If you rounded this to 3, you're gonna miss your last data entry. So that rounding up makes sure that you catch that last data entry. And you know your groups never overlap. We do our class boundaries to make them meet, but they don't overlap. Okay? Yes. Yes. Alright, so make sure you get your frequency. Put your tallies. I didn't put a tally here, but you probably tally. You put your tick marks there. That's fine. Make sure you go through and you make it
Do you
nice.
have to tally? You can do it.
You can do it in your head count, but just at the end, make sure this adds up to what you want it to add up to, so that you know you didn't miss one. Your midpoint, can everybody find the midpoint?
Yeah.
Now, look how nice this is. Your midpoint, add 4, add 4. See the midpoint now, Nick? We add 4 all the way down, so that's why we can... Yeah, you'll get used to this. Relative frequency, can everybody do relative frequency part over whole? Okay, give me 3 decimals. 3 decimals. Cumulative frequency, start with the smallest one and add down. Add 9. You're accumulating. It's like you're putting it in this basket that you're carrying. I have 3. I added my 9. Now I have 12. Then I added my 8. Then I have 20. Just keep accumulating them. And your class boundaries, if you use your upper class boundary, and the one that you have to use your upper class boundary is your OJI. The rest of them you can use your midpoint, which probably makes life a little bit easier to use your midpoint. I think it is. Good with the table? Okay.
Good now.
Good now. That's what I say. If you don't get that table, everything is off. Use your graph. I didn't have graph paper. I can't figure out how to get a decent graph paper that I can use. All my graph papers are too big. The boxes were too big. So I don't know how to get a good sized one for my smartboard yet.
You do some good. Excel for
It does?
yeah, the grid. Then you can add the boxes.
And then I can put the boxes in?
Yeah.
Okay, I'll try that. Okay, so now, most important, title, label, label. Make sure you label, okay? If you're going to increment, your increments on your y-axis have to start at 0. And to show that I'm going by ones, I just have to even do like 1, 2. Just to show you where my increments are. Because you don't know if I only put 1, did I go by 2s? Do I go odds? Did I go, well, whatever. 1 usually kind of tells you, but just make sure you give me some kind of a thing. You don't have to label all of them. These guys, yes, you have to label. I use midpoints. If you use your upper class boundary, it's going to be right here. And that's going to have to be your first lower class boundary. So if you use your upper class boundary, it's along here. Good? With this? Alright. This one should be the same look as your frequency polygon. Except in the frequency polygon, you're taking your midpoints of each one of these. And you're making a line segment. That's where your line segments come from. See them down here? See the line? We just had to come one more over and one more down here.
And you could just make another midpoint for that. Add one.
Yeah, no, another midpoint, but give yourself enough space when you do that so that you're not cramming that midpoint in. You know what I'm saying? So if you have to add 2 midpoints and 5 classes, make 7 lines. But that should have the same look as this. Some people like to look at the polygon rather than the histogram. It just, I think it shows the steepness, like the growth and the steepness a little bit more.
Okay.
Yes.
Where'd you put
The
29.5?
29.5, this is your midpoints that you have to use, right? And it's going to start right here. However, because this would be standing here in the middle of your graph, you got to drop it down one more midpoint. So take your class width and subtract 4. Your class width was 4.
Oh.
So just subtract 4. And Jada, you have to do it on the other side as well. Because this is the last one here. See it? So your graph would kind of be sticking in the middle of the page. Add one more midpoint here. Just take your class width and add one more. We never use those, but it just kind of borders your graph. So you should be able to see some kind of similarity in here. And your relative frequency is going to look just like your frequency histogram, except your y-axis is in relative frequency. Remember, do that like money. You don't want to make this say 0.5 and then 0.10, because 0.5 is 50 cents versus 10 cents. So make sure you think money when you do your relative frequency thing. And your bars are going to look the exact same. Again, midpoints work out nicely for this guy. The midpoints you really need for your frequency polygon, and so you might as well just keep your midpoints through all 3. I think they're easier. Make sure you give titles. Make sure you label your X and your Y axes. Yeah? Okay? And your OJI, your cumulative, shows growth. We have to drop the front end, 1 extra midpoint. Just take your class width and subtract it from the first midpoint. And remember, that could come into a negative number, and that's okay. Just leave it. It just looks a little weird. But don't drop the last one off. You want to show growth. This OJI will never decrease. If there's no growth for one class, you'll just see a horizontal line, but it'll never drop back down. Questions? Question. Good point. Thank you. So make sure you use your class boundaries here. Upper class boundary.
It's only on the OJI, right?
Only, well,
And
you
you have
would
to
use it
use-
on the histogram as well.
But you have to use.
You have to use it on this one. And the reason you do that, the first one is your first lower class boundary, but the reason you do that is because you show growth to the end of that class, not to the midpoint, technically, to the end of the class. Okay? Questions on any of these? No? I know they're annoying to have to do a lot of them, but I want you to be able to get this. This one was the same type of setup, except they had you do 6 classes, and again, this class width was 4. Regardless of what this is over here, if it was 3.01, you're still going to 4. You always round up on this one, always. We're only going to have whole numbers when we do this, so we're fine with doing that. Again, find your frequency, find your midpoints. Here's your class width right here, either any two lowers or any two upper limits. And again, you can find your midpoint and add 4 all the way down. Your frequency should add up to, again, this happened to add up to 24. Which should your relative frequency add up to? 1. Good. Because it's all your parts. So all your parts have to add up to 1. See that? Oh, you're stressing. Okay. That looked like a raised hand. Okay, and again, labels, titles. You can use the same title for all 4 graphs, because essentially it is the same title. Classes of ages we use, these were retirement ages. What else is in here? You guys tell me if you have any questions. It's basically the same as before. Your frequency polygon, again, I use the midpoints. These are your class midpoints. And drop it down and raise it. Because otherwise your graph is going to sit in the middle of your paper. Questions? No? Okay. All right. Relative frequency, again, classes, title, and these have no things here at all.
Why are they 0.05? Because the way I went up for the relative frequency, I started at
The thing you shouldn't do is, try not to cut your y-axis, only cut your x-axis. Don't cut your y, because what it does, it looks like there's no growth at all when you started at the lowest. It just like it compresses it. So you only can cut your x-axis. What happens when you start like this? You started at, what'd you start at? Point what? You started at 0.40?
Yeah, and went up. Because it's like 0.125.
Oh, okay. All right, let's.
Or 0.041, yes, I think 0.04.
All right, let me just talk about that a second. That's why I say think money. When you think money, it's easier. When you do that, 0.40, your first one, 0.04, is 4 cents. 0.40 is 40 cents. So your first one is only 4 cents. So you want to start it where the 4 cents is. That's the 4 cents right here. That's 4 cents. This is 40 cents. See the difference? Yeah, you never want to cut your y-axis. You always want to start your y-axis at 0. If you cut your y-axis to the first one, it looks like there was nothing there. You kind of distort the data a little bit. So, make sure you start it at the 0, 0. And that's where I say think money, because 4 cents, I can start it at, I could go every 0.05. I could do the 5 cents, the 10 cents. Most of the time you're going to see these as 5. Sometimes you'll see them as 2 if there's a lot of classes, and then the relative frequency is a lot smaller because you share it with like 10 classes. You might be able to go by 2 cents. But think this as money. Okay. Again, use the midpoints. You can use your upper class boundary. I would use whatever you use on your frequency histogram, use the same exact thing. Oh. And your frequency, here's your ogive. Did I use the class boundaries this time? Yeah. Here's your upper class boundary. Again, you're going to have to use your first lower one. Don't raise the higher one, just the lower one. You want to see growth in this. And you want these to be line segments. Make sure they're not smooth curves. You want to show the steepness. You want to show the difference between these. Okay? So talk